Hello and welcome to this training video all about function facts. As part of your college algebra training, you'll be filling out an assignment that looks something like this. It is a function fact sheet. You'll be filling out this fact sheet specifically for logarithm functions. College algebra students are required to fill out a page like this for every single type of function that they learn about, but you'll just be doing it for logarithms specifically. And you actually already know a lot of the information that you'll need in order to fill out the function fact sheet for logarithms from previous videos and assignments that you've already done for your training. So we're not going to talk about these things here on the left, but we will talk about these 5 ideas here to help you to fill out that function fact sheet for logarithms. And we'll talk about these principles in general, and then it'll be your job at the end of the video to see if they apply to logarithms and then to fill out that function fact sheet. The first thing is a turn. A turn is a place in a graph where it changes from increasing to decreasing, or vice versa, from decreasing to increasing. So anything that looks like this. So the vertex on an absolute value or on a parabola, those are turns. Or these minimums and maximums on a sine wave, right? Those are places where it changes from increasing to decreasing. Obviously, not all graphs have turns. So you want to think about for this fact sheet if a logarithm has a turn or not. Next thing is continuity. A function is said to be continuous in a specific interval, maybe over its domain, if there's no break in the graph. And what we mean by break is if you were to trace it, so here's some continuous graphs. I think about it as if I take a pencil. So I take a pencil and trace it, I won't have to lift my pencil. I can just keep it on the page for all of these, right? I can just keep it going. It's continuous for all of these graphs. It'll look like this, not continuous. It'll have holes or asymptotes between parts of the graph, where if I were to trace it, I'd have to pick up my pencil to trace the other side of the graph. So I always do the pencil test for continuity. Again, think about, is a logarithm continuous? One-to-one. In a one-to-one function, every element in the y values, the range, is paired with exactly one element in the domain, or the x values. So a function itself maps every input to an output, but a one-to-one function, every input has only one output. No outputs are repeated. Okay? So these are one-to-one. You can see that if I look at an x value, it has only one y value, and the y values only have one x value that are mapped to them. And that's true for all of these. Down here on the left, this logistic function might look like it has some repeated y values, but there is an asymptote there, so it's just getting really close to the same y value, but it's not repeating. You may have heard of the vertical line test for functions to see if a graph is a function. There is something called the horizontal line test for one-to-one. If you can draw a horizontal line and only hit one part of the graph, right, that's not a very good horizontal line, but you get the idea, then it is one-to-one. If you can't do that, it is not one-to-one. So any of these have repeating y values. These are functions, but not one-to-one functions. So absolute value, quadratic functions are out, trigonometric functions are out. But you got to consider, is a logarithm one-to-one? All right, moving on to concavity. I always like this one because I like talking about the smiles and the frowns. Concave up means it's a smiley face, right? And the concave down is a frown. It even rhymes, frowny face. It deals with how the graph is curving. So, for example, on a sine wave, you'd have concave down, and then it changes to concave up. Some graphs are always one or the other. So, for example, a parabola is always concave up or always concave down. And where it changes on that sine graph, this point right here, is actually the last thing we're going to talk about. This is called an inflection point. An inflection point is a point on the graph where the concavity changes from concave up to concave down, or the vice versa, right? So if it was concave down to concave up, it'd be like that sine wave we're just looking at. So this is the point on the graph where the concavity changes. Just like a turn, not all graphs will have an inflection point, right? So for example, a parabola is always concave up. It doesn't ever change back to concave down. All right, you're ready to answer these questions about a logarithm. Here's what the graph looks like to help you out. Is there a turn? Is it continuous over its domain? Is it one-to-one? Try drawing some horizontal lines there. Concave up, concave down. Does it change? And with that, does it have an inflection point? So I'm going to let you answer those questions for yourself, and then you are ready to fill out that function fact sheet. Again, if there's anything in this video, or not in this video, that you need to fill out that form, it'll be in a previous video or on a previous assignment. So good luck with that. See you in the next video.